Right, okay. Students, can you all hear me? Can you hear me, students? Right, okay. Right. Okay, good evening for all of you. Yeah, no need to unmute. So you can use the chat box to send the messages, okay? Use the chat box, okay? Right. So good evening, students. Today we are going to conduct third session of our pre-level foundation program, right? So today we have to discuss topic number 4, mole concept and stoichiometry. Turn to the page number 11 in the PDF, okay? So without wasting time, let's quickly move to the topic number 4. Topic number 4, mole concept and stoichiometry. Right? So when we discuss about the mole concept, actually, the first thing that I want to discuss with you is, students, what does mean by mole, right? In O-level time also you have learned about this term mole. So what does mean by mole? So mole is the smallest unit, right, that we use to measure the amount, right? In order to measure the amount, the basic unit that we're using is mole. But when we go beyond that, right, definition wise, give me a proper definition for the moles using chemistry knowledge that you have. Anyone? Put your answers in the chat box. What does mean by mole? A simple definition. What is your opinion? Mole. How do you define the mole? Right? Any definition, anyone? If I ask you what does mean by mole, how do you define that? In chemistry? Quickly. Anyone? Right. So remember, mole means actually, we can consider that Avogadro number of particles in a system, right? We consider that one as mole. That means 6.022 10 to the power 23, right? Number of particles. We consider that one as moles, right? Now just imagine I have Avogadro number of marker pens, which means I have 1 mole of marker pens. Remember, in chemistry, we are using this 1 mole, the concept of mole, in order to simplify the numerical values that we are using in chemistry. Students, we know that practically it's not possible to measure this amount of atoms, molecules, electrons, protons. So therefore, we are taking a bulk amount, right? So that bulk amount that they have given us 1 mole, that's easy, right? Now in chemical calculations, we are using 0.2 moles of sodium carbonate, right? 0.04, 0.05 moles of potassium hydroxide. Likewise, so this is very convenient, This is very convenient to express the numerical values of the chemical substances that we are discussing. That's why we need the mole concept. So remember that 1 mole is containing Avogadro number of particles. Okay. Right. So if it is 1 mole is containing Avogadro number of particles. Now just imagine 1 mole of hydrogen. So what does mean by 1 mole of hydrogen? So 1 mole of hydrogen means we can say that Avogadro number of, right, 6.022 10 to the power 23 hydrogen molecules are there. Hydrogen molecules are there. Right? If I ask you number of hydrogen atoms, right, I'm going to ask you a question like this. Number of hydrogen atoms in 1 mole of H2 molecules. Then what is your answer? Just think and tell, right? 1 mole of hydrogen, right? That means Avogadro number of hydrogen molecules. My question is, how many hydrogen atoms are there in 1 mole of hydrogen molecules? What is your answer? Anyone? How many hydrogen atoms are there in 1 mole of hydrogen? Yes. Number of hydrogen atoms in 1 mole of H2, hydrogen molecules. So yeah, we can say that 2 into 6.022 10 to the power 23. Why? Yeah, in 1 molecule, right? So if I consider 1 molecule, there are 2 hydrogen atoms. Then there are Avogadro number of hydrogen molecules. Then if you ask to find out hydrogen atoms in Avogadro number of H2 molecules, then you have to multiply that one by 2 in order to obtain the hydrogen atoms. Okay, that's very easy. Now let's move to the questions that they have given regarding this topic. That's very easy, okay? First of all, MCQ questions. So there are 10 MCQs. So let's answer them, right? Let's see what is the first one. 1 mole of any substance contain. Students, very easy. 1 mole of any substance contain. Yeah, what is the answer? Now look at the two answers they have given, right? We have to be very careful. The first answer is 6.022 10 to the power 23 atoms. Second answer is 6.022 10 to the power 23 particles. Which one you are going to take? Atoms or particles? The question is 1 mole of any substance. It can be atoms, molecules, ions, electrons, protons, neutrons. So commonly we can say particles. So therefore here the best option that we can take is B. Question number 1, answer is B. Question number 1, answer is B. Okay. Number 2, the molar mass of carbon dioxide, right? What does mean by molar mass, students? What does mean by molar mass? Molar mass means, actually, you get the name, right? Molar mass is representing mass of 1 mole, right? Molar mass denoted by capital M, right? Right? Mass of 1 mole is considered as molar mass. Now, if I consider, right? If I consider mass of 1 mole of carbon dioxide, right? We have an equation, can you remember? So I told you that we have equation like simple n equal simple m over capital M in this way. So in this equation, simple n means number of moles, right? This is the mass and this is the molar mass. Okay. So what is the molar mass then? So we can consider that mass of 1 mole, right? If I consider oxygen, right? Molar mass of oxygen is, atomic number of oxygen is 16. So therefore 16 into 2. Remember, for the molar mass, there is a unit, grams per mole, right? Because molar mass means mass divided by the number of moles. So unit of capital M is grams divided by moles. That means grams per mole is the unit. Right? So therefore molar mass for oxygen is 32 grams per mole. Likewise. Right? Molar mass of H2O, hydrogen is 1. You have to remember the atomic numbers, okay? Right? In chemical calculations unit number 3, we are going to discuss in these things in detail. Now just remember, in O-level time also you have learned, right? Hydrogen atomic number is 1. Mass number is 1. 1 into 2. Oxygen is 60 grams per mole. Then 18 grams per mole. So here they are asking molar mass of carbon dioxide. What is the molar mass of carbon dioxide? Tell me, students, what is the mass number for carbon? What is the mass number for carbon? You know it. Yes, mass number of carbon is 12. Then there are 2 oxygen atoms. Summation grams per mole. So when you get the summation here, answer is 44 grams per mole. So this is the molar mass of carbon dioxide. Understood? This is the molar mass of carbon dioxide. Question number 2, answer is C. Raise your hand those who got the answer correctly before I discuss it. Raise your hand those who got the answer. Okay, good. It's very simple things, okay? Again, we are discussing these things, right? What you learn in O-levels, again, we will be revising it again, right? Our lesson number 3, unit number 3 is chemical calculations. In chemical calculations, we are starting from the atomic mass unit, relative atomic mass, relative molecular mass, right? Avogadro number, mole concept, what is the molar mass, right? We are starting everything from the beginning. Okay, so therefore don't worry if you have any issues in chemical calculations. If you had any issues in chemical calculations when you were O level, don't worry. In A levels, again we are going to revise. Again we are starting from the beginning, and then we are going to difficult calculations. Right? We are starting from small calculations, and we are taking you all to the difficult calculations. Right? Right. Question number 3. Look at this one. Right? 2 moles of oxygen gas contain how many molecules? What is the answer for this one? 2 moles of oxygen gas contain. Yes, Rana, your answer is correct. Yes, Shimak, your answer is correct. That is the answer. Very good. So how do you find out that? As I told you before, you don't have to note down these things, okay? These things are not compulsory. So you just listen and try to understand. I'm saying I told you. Right? So now they have given 2 moles of oxygen molecules, right? 2 moles of oxygen, O2. Then how many oxygen molecules are there? That means number of oxygen molecules. If you count the number of oxygen molecules, we know that 1 mole is containing. As I told you before, 1 mole is representing Avogadro number 6.022 10 to the power 23. So 1 mole is containing Avogadro number of particles. Then 2 moles are containing 2 into Avogadro number 6.022 10 to the power 23. So this much of oxygen molecules are there. Then I can find out number of oxygen atoms, right? Students, we know that when you consider one molecule, right? One oxygen molecule, right? One oxygen molecule is representing 2 oxygen atoms, right? One oxygen molecule is representing 2 oxygen atoms. Then the number of oxygen atoms will be, right? So we can consider, we should multiply this one by, they're asking here oxygen molecules. So therefore, no need to go for the oxygen atoms, but okay, anyhow, if you want to take the oxygen atoms, again, you have to multiply this one by 2, right? Remember that they're asking about the oxygen molecules, but here I have discussed about the oxygen atoms as well. Then 6.022 multiplied by 2, then what is the answer? 440 12.044 10 to the power 23. Right? That means 1.204 10 to the power 24 oxygen molecules are there. See, the number of oxygen molecules will be 1.204 10 to the power 24. Okay, I'll teach you how to play with these 10 to the power values. That's not a big deal. So therefore, question number 3, answer is B. Question number 3, answer is B. Raise your hand those who got the answer. Raise your hand those who got the answer. Good, very good. Now let's move to the question number 4. Right. Now let's move to the question number 4. In question number 4, they have given the number of moles in 27 grams of aluminium, right? 27 grams of aluminium. In other terms, what is this exactly? Students, what is the molar mass of aluminium? What is the molar mass of aluminium? Molar mass of aluminium is 27. So actually they have given mass of 1 mole. So this is the mass of 1 mole. Therefore, molar mass of aluminium, capital M, is 27 grams per mole. 27 grams per mole. So actually here they have given the number of moles in 27 grams of aluminium is 1. Question number 4, again answer is B. Second one is the answer, B. Right, that's very easy. Okay. And remember, there is a connection between the relative atomic mass and molar mass. Right, now look at this only. If I draw a table like this, so this is actually relative atomic mass. Relative atomic mass is symbolized by AR. Okay, then here we have molar mass. Molar mass is symbolized by capital M. Let me take the element here. Element. Let me consider 5 elements, right, randomly. Let me consider carbon, oxygen, sodium, sulfur, potassium, in this way. Okay, I got 5 random elements. Then what is the relative atomic mass of these elements, right? Let's go one by one. Carbon is 12. Oxygen, 16. As a chemistry student, you should know these things, right? Still 2027, your elder batch students are asking, do we need to remember these things? We have to remember, right? I have told them they are giving these values in the exam paper, but don't rely on them, right? As a chemistry student, you should know these things, right? These are very simple things. Sodium is 23. Sulfur is 32. Potassium is, we can take that one as 39 in this way. So these are the relative atomic masses. Then what is the molar mass? Molar mass means 12 grams per mole. Same numerical value, but we have unit like this. 16 grams per mole. Sodium, 23 grams per mole. Sulfur, 32 grams per mole. Potassium, 39 grams per mole. So likewise, we can take what? Molar mass in grams per moles, we can take the answer. So the difference between the relative atomic mass and the molar mass is relative atomic mass doesn't contain unit, but molar mass has an unit like grams per mole. That's the difference between relative atomic mass and molar mass. Understood? Even when we consider the molecules instead of elements, the same thing will happen. For an example, if I consider carbon dioxide, CO2, relative molecular mass of carbon dioxide is 44. Molar mass of carbon dioxide is 44 grams per mole. What is the difference? What makes the difference between the relative molecular mass and the molar mass? Only the unit. Still the value is same. Okay. So this is very small thing that you have to notice carefully, because in calculations, this will be important. In chemistry, remember, it's not like in physics. When you're doing a chemical calculation, you have to follow the units from the beginning, right? So normally in the A-level exam paper, they're allocating the marks. First of all, they're allocating the marks for the equation. First of all, they're allocating the marks for the correct substitution with the units. For the units also they are giving. Then they are giving marks for the final answer with the units. For the units, they are allocating marks. When you are doing the substitution, you have to do that. You have to do that with the units. If you are doing another step, in that step also you have to put the units. In the final answer also, you have to put the units correctly, right? That's how we are doing the calculations in chemistry. Okay, when we do calculations, we will understand it. Right. Then question number 4, answer is B. Now let's move to the question number 5. At room what is this RTP? Anyone? Yes, Mana, correct. RTP means room temperature pressure. What is STP? What is STP then? RTP means room temperature pressure. In chemistry, we are learning somewhere like in gas laws, unit 4 and unit number 5, energetics. STP, what is this STP? If RTP means room temperature pressure, what does mean by STP? S means, anyone? Standard temperature pressure. Understood? Remember, students, RTP means room temperature pressure. Okay. STP means standard temperature pressure. Now, RTP. RTP means room temperature pressure. So what is the room temperature pressure? So room temperature is actually, we can take 25 to 27. Okay. 25 to 27 degrees Celsius. And the pressure is 1 atm. So here, atm is actually the unit that we use to measure the pressure. That means atmospheric pressure. Likewise, now we are living in the atmospheric pressure 1 atm. Okay. So in order to measure the pressure, we have several units: atm, then Pascal, Newton per square meter, right? Mercury millimeter. Okay. Then bar, then PSI, torr. Likewise, there are so many units. I'll teach you these things under unit number 4. Okay, we have unit conversions. So this is 1 atm. Actually, 1 atm is equal to 1,325 Pascal. Approximately, we are taking this on as 1 into 10 to the power 5 Pascal. Okay, or Newton per square meter. So that is what we consider as 180. Then the next thing is STP. STP means standard temperature pressure. Standard temperature pressure. So standard temperature pressure, there are two conditions, right? So there are two conditions we are taking. One is 0 degrees Celsius and 1 atm. And the other one is 25 degrees Celsius and 1 atm. Actually, when we are doing the calculations in gases, unit number 4, we are using this condition. When we are doing calculations in energetics, unit number 5, we are using this condition 25 degrees Celsius, 180. Actually, this is what we are considering as STP majorly, right? But this is also a condition that we can call as standard temperature pressure. Okay. Anyhow, now you know about what does mean by RTP and STP. At RTP, room temperature pressure, 1 mole of any gas occupies a volume of. Students, remember, any gas, right? Right? 1 mole of any gas, 1 mole of any gas will occupy, right? Will occupy 24 cubic decimeter volume at room temperature pressure. Remember that one. That's a theory. Okay. Now it becomes your general knowledge, right? In unit number 4, we are learning that one. It's like this. At the standard temperature pressure, 1 mole of any gas will occupy 22.4 cubic decimeter. This is the theory that we are learning under unit number 4. But here the question they're asking, 1 mole of any gas, right, at room temperature pressure will occupy volume 24 cubic decimeter. Remember that, okay? At the standard temperature pressure, 22.4. We are learning that one as a theory, okay? At room temperature pressure, we are taking that one as 24. Understood? So therefore, here, question number 5, answer should be C, 24 cubic decimeter. Right? Question number 5, answer should be C. Right? It's a very simple theory that we are learning in A-levels. If you have any doubts, put your doubts in the chat box, okay? Right. Now let's move to the question number 6. Question number 6, they're asking the empirical formula of a compound with carbon to hydrogen is 1:2. They're asking the formula, empirical formula. Carbon hydrogen ratio is given. They're asking the empirical formula. Okay. It's very simple. I'll explain you that one through a table. Look at this table, will you? Right. You should know the difference between empirical formula and the molecular formula. You know what does mean by molecular formula. Molecular formula means the exact number of atoms mentioned in the compound. Right. So let me put molecular formula here and then empirical formula in the other side. Molecular, and here let's take empirical. Okay, in this way. Right. Now look at this one. Here also let me take 5 examples. C6H12O6. Then let me consider C4H10. Then H2O2. After that, N2H4. Third one, C3H8. Okay. So here I have taken 5 molecules. So these are the molecular formulas of those compounds. The first one is known. Tell me, students, what is the first one? What is this formula? You know this compound. C6H12O6. What is it? Yeah, that is glucose. Glucose. Remember, empirical formula means the simplest ratio between the atoms in a molecule. Right? Now here you can see that ratio is 6, 12, 6. Carbon, hydrogen, oxygen. Ratio is 6, 12, 6. If you simplify it, what will be the empirical formula? 1, 2, 1. This is the simplest ratio. Then I can write down it. 1 carbon, 2 hydrogen, 1 oxygen. This is the empirical formula. Understood? Now let's take carbon is to hydrogen, second one. Ratio is 4 is to 10. That means 2 is to 5. Then we can take C2H5. C2H5 is the empirical formula. Look at the next one. 2 is to 2. That means 1 is to 1. HO. Here 2 is to 4. That means 1 is to 2. NH2. C3H8. Remember, we can't simplify that. We can't simplify it further. So therefore, empirical formula and the molecular formula both are same. Empirical formula and molecular formula both are same. Right? So that means, students, empirical formula means the simplest ratio. Right? The simplest ratio between the elements. Between elements in a compound. Understood? So therefore, in this one. Now, according to the given question, they have given that simplest ratio is 1 is to 2. Right? Therefore, empirical formula is simply we can take that one as CH2. Okay. So therefore, question number 6, answer is B. Raise your hand those who got the answer for that. Question number 6. Anyone? Okay, good. Right. Okay, now let's move to the next question. Question number 7. Let's see. If you have any doubts, put your doubts in the chat box, okay? Right. Now, question number 7. In the reaction, so here they have given 2H2 reacting with oxygen to produce 2H2O. How many moles of H2O are produced from 4 moles of H2O? Remember, students, this question is from the stoichiometry, right? Look at our topic, mole concept and stoichiometry. What is this stoichiometry? It's a very simple thing, okay? Stoichiometry means in a reaction, the ratio between the reactants or the products where they are reacting, right? Now you can see that according to this reaction, if I consider 2 moles of hydrogen reacting with 1 mole of oxygen to produce 2 moles of H2O, then I can say that hydrogen, oxygen, water reacted mole ratio is 2:1:2. This is what we consider stoichiometry. This is what we consider stoichiometry. Stoichiometry means how much of, that means as a ratio, how many moles reacted with reactants, all the reactants and products as a ratio, stoichiometry ratio. Understood? Right? I can say that 2 moles of hydrogen reacted with 1 mole of oxygen to produce 2 moles of water. Right? And it should be the balanced reaction. Otherwise, we can't take it. Okay? Right? It should be the balanced reaction. Now, this reaction is perfectly balanced. Right? Then, now they have given 4 moles. Right? So, if 4 moles of hydrogen reacted, right, they're asking how many moles of H2O produced. If 4 moles of hydrogen react, then how much mole of oxygen? So here double, that means 2 moles. Here, how many water? Right? Because it follows the reaction stoichiometry, right? It's following the 4:4 is following the reaction stoichiometry ratio. That's why 4 moles of H2 is producing 4 moles of H2. According to the reaction, the same number of moles should produce as hydrogen. Hydrogen and H2 both are same number of moles. So therefore here answer should be C. There should be 4 moles of H2O. Question number 7 answer is C. Raise your hand those who got the answer. As C. Simple, right? Very simple. The question number 8 is very simple. I have already told you. Molar mass is defined as mass of one atom, mass of 1 mole of substance, mass of 1 molecule, volume of gas. We know that molar mass means mass of 1 mole of substance. So therefore, question number 8 answer is B. It's very easy. Question number 9. It's a calculation, right? Okay, students. Have you done this calculation? Tell me the answer. The mass of 0.25. Yes, Rana, your answer is correct. That's the answer. Very good. You have already done these calculations, right? Yes, Shimak, your answer is correct. That is the answer. The mass of 0.25 moles of calcium carbonate. They have given the molar mass also, right? How do you find out? Can you remember the equation that we're using? So we can take that in this way. So let me draw the magic triangle. Here's the magic triangle. Simple M, capital M. We know that according to this magic triangle, simple M equal simple N multiplied by capital M. Here simple M over simple N is equal to capital M. Then simple M over capital M is giving simple N, right? So this is the magic triangle. So here they are asking the mass of number of 0.25 moles of calcium carbonate. So therefore we can use this equation, this one, right? According to that equation, mass of calcium carbonate is How many moles are there? 0.25. What is the molar mass of calcium carbonate? 100 grams per mole. Now look at this one, right? Students, this is the way that we are doing the calculation, right? We have equation. This is the substitution with the correct units. Can you see that? I have substituted. Now, these are the things that you should know, right? These are the things that you should know about A-level chemistry before you enter to the syllabus, right? So you have to do the calculations in a disciplined way. That means you have to use the equation, substitute with the units, because some of the students don't substitute these units. Then you are going to lose some marks. It can be 1 or 2, but that's also very important for us. Got it? So moles and per moles will cancel off, right? So therefore 0.25 multiplied by 100 means 25 grams, right? Even in my final answer, unit is available. So we can see that answer is A. Question number 9, answer is simple A. Question number 9, answer is simple A. All right. Right. Now let's move to the question number 10. Question number 10. So they have given the number of atoms in 1 mole of oxygen. 1 mole of oxygen. So here we can say that 6.022 10 to the power 23 oxygen molecules are there. Then the number of oxygen atoms will be 2 times of that. Oxygen atoms. Okay. So therefore here answer should be, so 12.044 10 to the power 23. That means 1.204 10 to the power 24 oxygen atoms. So therefore, answer should be C. Question number 10, answer should be C. Okay. So that's all. So these are the MCQs that they have given under mole concept and stoichiometry. That's very simple, right? Now let's move to the structured essay questions. The first question is define one mole. Define mole, right? So we can define it like this. Number one, Avogadro number of that means 6.022 10 to the power 23 particles is known as 1 mole, a mole, right? Question number 2, calculate the number of moles in 32 grams of water. Yes, Luksha, you are correct, right? Students, you can use that equation, right? So they have given 36 grams of water. First of all, tell me what is the molar mass of H2O? What is the molar mass of H2O? So we know that molecular mass of oxygen is 60. There are 2 hydrogen atoms. So therefore 18 grams per mole. This is the molar mass. So they have given mass of water is 36 grams. Then use the equation simple n equals simple m over capital N. Number of moles equal to mass divided by the molar mass. 36 grams divided by 18 grams per mole. Grams will cancel off. Per moles will go to the numerator. 1, 2 here. Answer is 2 moles. Right? Look at my perfect answer. 2 moles. So here, answer is 2 moles. Raise your hand those who got the answer. Even you can do that one in your mind. It's not a big deal. Right? Very easy. Right. Now let's move to the third one. Question number 3. Determine the mass of 0.1 moles of sodium chloride. Right? So now here they are asking mass. Right? Molar mass is given. Sodium chloride is 58.5 grams per moles. Number of moles of sodium chloride they have given 0.1. Then students, we can find out the mass. Mass equal number of moles multiplied by the molar mass. 0.1 moles multiplied by 58.5 grams per mole. Per moles will cancel off. Answer is 5.85 grams is the mass of sodium chloride. Okay. Raise your hand those who got the answer like 5.85 grams. Good. Students, when O-level result is coming? Don't know. Approximately June, July? No, not April. I don't think they are giving that much earlier. June again, eh? Yes. June. March, April, May. Yeah. After 3 months. What is the answer for question number 4? Anyone got the answer for question number 4? Okay, Shimak, let's see whether your answer is correct. They're asking calculate the mass of magnesium oxide formed by 6 grams of magnesium. You have to think about the reaction stoichiometry and get the answer. What is the answer for fourth one? Rana, your answer is correct. That is the answer. Yes, you are correct. Yeah, your answer is correct. Around mark. Now let's move to the question number 4. So that's a simple calculation, right? So they have given question number 4. The balanced chemical reaction between magnesium and oxygen producing magnesium oxide. In order to balance the reaction, we can put 2 here. So they have given calculate the mass of magnesium oxide formed by 6 grams of magnesium. Students, let me find out here number of moles of magnesium. We know that the equation we can use number of moles, mass divided by the molar mass. Number of moles of magnesium, they have given 6 grams. Molar mass is 24 grams per mole. Grams will cancel off. 1 here and 4. So therefore, number of moles of magnesium will be 1 over 4 moles. Right? So let me keep that one as a fraction. Can you see that the reaction stoichiometry between magnesium and magnesium oxide? 1:1. Right? 2:2. That means 1:1. That means magnesium moles and magnesium oxide moles Same number of moles. That means reaction stoichiometry is 1:1. Then can't we say that number of moles of magnesium is also same as number of moles of magnesium oxide is also same as moles of magnesium. Therefore, magnesium oxide moles will be 1/4. Same thing. Now you find out the molar mass of magnesium oxide. Magnesium is 24, oxygen is 16 grams per mole. Then the summation is 40 grams per mole. Then you have to find out the mass, isn't it? In order to find out the mass, we have to use number of moles multiplied by the molar mass. Therefore, mass of magnesium oxide is 1/4 moles multiplied by its molar mass, 40 grams per mole. Per moles will cancel off 1, 10 here. So therefore, answer is 10 grams. 10 grams, right? We found the number of moles of magnesium. Then we found the molar mass of magnesium oxide. Magnesium oxide moles also 1/4. Then moles multiplied by molar mass, it's giving the mass in this way. Raise your hand those who understood the calculation quickly. If you have any doubts, you can ask me. If you have any doubts, put your doubts in the chat box. We can discuss them. Now, question number 5 is very interesting. Let me see your answer for this one. Do the calculation. Let's see. Okay, Rana, let's see whether your answer is correct. Right. Now let's move to the question number 5. In question number 5, yes, Shiva, let's see. A gas occupies 600 cubic centimeter at 27 degrees Celsius at 180 m. Find its volume at 87 degrees Celsius if pressure is constant. Right. Now let me teach you something like this. Students, in unit number 4, we are learning an equation like this: P equal nRT. This is known as ideal gas equation. What is this? This is known as ideal gas equation. What does mean by ideal gas and everything? You will be learning that one under unit number 4. So here pressure means, here P means pressure. Pressure created by the gas. V is the volume. N means number of moles. And capital R means universal gas constant. That's a constant value. Universal gas constant, 8.314 Newton meters per Kelvin per mole. Don't worry about these things, okay? Then T means absolute temperature. What does mean by this absolute temperature? Absolute temperature means the temperature measured by Kelvin. Temperature measured by Kelvin is considered as absolute temperature. What is the ideal gas equation? P equal nRT. P is pressure, V is volume, N means number of moles, R means universal gas constant, and T means absolute temperature. Got it? Then according to that equation, right? So they have given the same pressure, right? That means pressure is a constant value. Then the amount of the gas is also constant, right? Then R is anyway constant. No? That means, students, I can say V equal nR over P into T. N is a constant. The gas amount of the gas is a constant. Universal gas constant. Pressure is also constant. Then I can say that this is a constant. V equal KT, constant. That means volume is directly proportional to the temperature. We are learning this one as Charles' law, right? Now we don't have to learn it, but remember there is a connection like this. If you consider an ideal gas, right? When pressure and the amount is constant, we can say that volume is directly proportional to the temperature. That means when volume increases, temperature is also increasing. Right? We know that when the temperature is increasing, the things are expanding, no? Right? Think in that way. Volume increasing, temperature is increasing. Then I can make a connection. Like this. Right? V1 over V2 is equal to T1 over T2. Like this. Volume ratio is equal to temperature ratio. Now you can apply that. What is the volume? At the first situation, 600 cubic centimeter. Then volume of the second situation only we are finding. The temperature is 27. We know that we have to convert into Kelvin, right? Tell me, when you are converting Celsius into Kelvin, what we have to do? In order to convert that one into Kelvin, Celsius to Kelvin, what we have to do? You have learned it. In order to convert Celsius into Kelvin, what we have to do? Anyone? Yes, at 273. That means you have 300 Kelvin. Then 87 degrees Celsius at 273. Then what is the answer? 0. Then 16, 360, 360 Kelvin, right? Then here 300 Kelvin, here 360 Kelvin. Kelvin, Kelvin cancel off. 0, 0 will cancel off. Let me cut off these zeros. And here I can say 1 here, 12 here. Then V2 equal 12 multiplied by 60 cubic centimeter. That means 720 cubic centimeter. Here's the volume. Can you understand? I saw that some of you got the answers. Very good. Raise your hand again, those who got the answers. Raise your hand again, those who got the answers before I do the calculation again. Yes, very good. Shimak and Rana, very good. That's all. Now we can move to our next topic. Topic number 5, states of matter. That's very easy. Right. Now, let's move to our next topic. Topic number 5, states of matter. In this way, right? Now let's move to the MCQs. Easy. Matter can exist in 1 state, 2 state, 3 states, and 4 states. So what are the states of matter? Yeah, see, we know that we have solid, liquid, and gases. SLG. Okay. And some consider plasma state also, but in chemistry, we have a lesson known as gaseous state of matter. At the starting of the lesson, we are discussing that there are 3 states of matter, okay? But some consider that plasma is also a state of matter, right? But majorly, we are considering these 3 states. What are they? Solid, liquid, gases, right? Right. So question number 1 answers. Question number 2. The particles in a solid are far apart and move freely, close, packed, and vibrate in fixed positions. Yeah. Randomly arrange and move rapidly, not in contact at all. Students, solid particles means actually they are packed and they are closer to each other, right? And they have vibration motion. They can't move. But gas particles are not like that. So other properties actually they have given are belongs to gases, right? Far apart and move freely, right? Randomly arrange and move rapidly, not in contact at all, right? So these are some kind of properties of gases. But when you consider solid particles, they are closely packed and vibrate in fixed positions. So therefore, question number 2, answer is B. Which of the following has the strongest intermolecular forces? Right? Yes. Strongest intermolecular forces. Solid, liquid, gas, liquid, solid, plasma. Right? Students, now when you consider a gas system, right? So the particles are moving randomly here and there. And when you consider liquid system, yes, they have some spaces, right? They are arranged in this way. This is liquid. But when you consider solid particles, the particles actually arrange in a proper manner, right? In this way, they are very close. Then tell me, when you consider 2 particles in this state, right? Gas, liquid, solid. Then tell me in between which particles there will be intermolecular forces, interactions, right? Gas or liquid or solid? Solid. Solid particles, understood? Solid particles are packed closer to each other. So therefore, the intermolecular interactions are high. Understood? Right? If I ask you a question like this, which state of matter is having the highest kinetic energy? Highest kinetic energy. Highest kinetic energy? Gases. Because gases are having space, lot of space, and they are moving randomly here and there inside the container, right? Understood? So the random motion is high in gases, but in solid particles, there is, right? So therefore, remember students, in solid particles only we can see, right? Highest Intermolecular, strongest intermolecular forces. Strongest intermolecular forces are in between particles in solid. So, question number 3, answer is C. Raise your hand those who got the answer as C. Good. Yeah, let's move to the fourth one. Diffusion occurs faster in solid, liquid, gases. First of all, tell me what does mean by the diffusion? Students, diffusion means particles are moving from, right? So that means the particles are spreading from one place to another, right? Particles are spreading from, in any substance, particles are spreading from one place to another. So it is fastest in solid or liquid or gases. Gases, right? Can you remember now? We know that we are using a perfume bottle, right? In a perfume bottle, here we have the knob like this, right? Right? So we can spray from here, there will be a small hole. So when you press this one, what will happen? Right? So spray is actually, particles are spreading. So this is what we consider as diffusion, right? In this way. So that is actually high in gases. Gases are spreading easily. So therefore, question number 4, answer is C. So these things are very easy, right? The process of a solid changing directly into a gas, right? Do you know that the names that we're using uh, for these conversions of states, right? I'll give you a chart that we are learning in unit number 4. In your resource book, actually, they have given this chart. But it's okay. Now you can learn it because this is actually a common general knowledge that you should have related to chemistry. Solid and gases. In this way. Liquid to gas. What is that process? Liquid to gas process is known as? Yes. Liquid to gas process is known as evaporation. Right? Then gas to liquid process is known as liquefaction. Right? Liquefaction. Or else we can use condensation also, correct. Liquid to solid. What is it? Liquid to solid, we can consider solidification. Right? Or else freezing. Solid to liquid, melting. Melting, no? Solid to liquid, it's melting. Then solid to gas. Solid to gas is sublimation. Solid to gas, sublimation. Then gas to solid, deposition. Deposition. Solid to gas is known as deposition. Right? Liquid to gas, evaporation. Gas to liquid, liquefaction. Liquid to solid, solidification, or else freezing. For the liquefaction, we can use condensation. Solid to liquid, melting. Solid to gas, sublimation. Gas to solid, deposition. Then here they are asking, the process of a solid changing into a gas is called what? Sublimation. What is, students? Sublimation. So therefore, question number 5, answer should be B. Raise your hand those who got the answer as sublimation. Good. Next one, question number 6. The pressure of a gas results from atoms colliding with each other, molecules colliding with container walls. Yeah. Vibration of ions, evaporation of liquid. Right. Good. First, remember now, according to that ideal gas equation I told you, PV equal in RT, I told you in that equation pressure. How that a gas is producing pressure. Remember, students, a pressure is actually a force, right? Newton per square meter, a force created on square meter, right? Square meter of area is known as pressure. So gas molecules are striking the container, right? So the gas molecules are striking on the wall of the container. Then only the pressure is created. Okay. Then only the pressure is created. Remember that a gas is creating pressure inside the container by striking the wall of the container. That's how the pressure is created. In that manner, the pressure of a gas results from molecules colliding with container walls. Question number 6, answer is B. Right? Students, remember these things as general knowledge actually. Right? In gases, we are learning this one, but you should remember this one, right? Question number 7. When a gas is cooled at constant pressure, its volume. What do you think? Yeah, can you remember that connection I told you? If the pressure is constant and if the amount of the gas is also constant, volume is directly proportional to the temperature. I told you. V means volume, T means temperature. That means when the volume increases, temperature is increasing. When the volume decreasing, temperature is also decreasing. Okay. Then they have given when a gas is cooled. Remember, when a gas is cooled means we are going to decrease the temperature. Right? So when it is reducing its temperature under constant pressure, what will happen to the volume? Volume also decreasing. Right? So therefore, simply we can take the answer. Question number 7, simple B. See how easy these things are. Very easy. Right? These things are very easy. Question number 8. According to the kinetic theory, okay, I'll briefly explain kinetic theory. So for the gases, we have the theory known as kinetic theory, molecular kinetic theory. In this kinetic theory, we are making some assumptions on gases. The first thing is, students, these gases are actually not having intermolecular interactions, neither repulsions nor attractions. They are moving randomly here and there inside the container, right, in a straight line, right? Random motion, but straight line. And they are point masses. Compared to the volume of the container, volume of a gas particle is negligible. That's why we consider gases are point masses. Understood? Right? So they are moving randomly here and there. The pressure of a gas is created by the force created by a gas particle when it is striking on the wall of the container. So these are the assumptions that we are making in molecular kinetic theory. So here they have given, according to the kinetic theory, gases consist of closely packed particles, particles in constant random motion, heavily compressed atoms, stationary particles. Closely packed particles, students, we know that solid particles only behaving in that way. Stationary particles means same thing. They are not moving. Heavily compressed atoms. No. It's not compressed. Second one, B, particles in constant random motion. That's what I told you. In the kinetic theory, we are assuming that the gas molecules are moving here and there randomly, random motion. That is known as Brownian motion. Remember, students? Gas molecules are moving in a random motion. Actually, it is known as a Brownian motion. That means in a zigzag way, right? In a zigzag way, like this. In a zigzag way, they are moving like this. This is actually known as Brownian motion. In a zigzag way, they are moving, right? So this is actually the same particle. I'm telling you that they are moving here and there. So this is known as Brownian motion, right? Brownian of gas particles. Okay. So question number 8, answer should be B, right? Question number 9, the temperature at which a solid turn into liquid is the solid is turning into a liquid. What is it? Melting. So therefore it is, yeah, answer is C, melting point. Question number 9, answer is C, melting point. Question number 10, Brownian motion is caused by movement of air currents, collisions of liquid gas particles with small particles, electromagnetic radiations, evaporation. Students, these are small particles, they are colliding, so they are moving in this way. So therefore answer is B. Brownian motion is caused by collisions of liquid or gas particles with small particles. So therefore question number 10, answer is B, right? So these are very simple theories on gases, right? Actually, they have mainly focused on gases. The reason is, students, we have a lesson known as gaseous state of matter. So that's why I have focused more on the gases. We are discussing in detail what is the ideal gas law, Charles law, Boyle's law, Avogadro law, combined gas law, Dalton's law of partial pressure, what is a real gas and ideal gas, difference between real gas and ideal gas, right? How real gases can be an ideal gas. So we are discussing these things under gaseous state of matter, right? So this is a small introduction for the gases. Okay. Now we can move to the structured essay questions. Right, okay. Right. Now let's move to the structure essay questions. Right. Question number 1. Describe the arrangement and movement of particles in solids, liquids, and gases. We can simply tell that solids means they are closely packed. And when we consider liquids, liquid particles, so they are close but move freely. Okay. Then gases, we can consider gases far apart, and move rapidly. Okay. So here is the arrangement and the movement. Okay. Solid particle doesn't have any movement, they are vibrating. Got it? Question number 2. Explain why gases are compressible but solids are not. Right? So what is the reason behind that? Right? We know that when we consider gases, the molecules actually far apart. So therefore we can compress. There are spaces, enough spaces in order to compress. But solid particles are not like that. We can't compress them because the molecules are arranged closely. Ne? So therefore we can tell that in gases, molecules are far apart. Therefore, they are compressible. But when you consider gases, when you consider solids have little space. So incompressible. Incompressible. Understood? Right. Now look at the question number 3. Question number 3, they're asking, in question number 3, they're asking when a gas is heated at constant pressure, its volume increases. Explain using kinetic theory. Now it's very easy, students. Remember, now just imagine we have a gas inside the container. We are heating. We are heating it. We know that heat means actually thermal energy, right? So that thermal energy will absorb by the gas particles. Tell me the energy conversion there. That thermal energy will convert into which energy? Right? So that thermal energy will absorb by the gas particles. That thermal energy will be converted to which energy? Right. Thermal energy will be converted into which energy? Right. Remember, students, thermal energy will be converted into kinetic energy, right? So that's how that should be explained by the kinetic theory, right? So that means when we are heating the gas sample, we are heating it, right? Then speed of the particles are increasing. Speed of particles, speed of particles increase. Okay, speed of particles increase. So when the speed of the particles are increasing, the collisions are increasing. That means the molecules are colliding because speed is increasing. So I can write down the gas particles are colliding more. They will collide more. They will collide. So when they are colliding, what will happen? They are expanding, right? Expand. So expanding means what will happen to the volume? Volume is increasing. Volume increasing. This is how when we increase the temperature under constant pressure, the gas is actually increasing their volume, right? When we are heating, the speed of the particles, molecules, gas molecules are increasing. Therefore, they are colliding more. The collisions will take place more. Therefore, expanding. Gas molecules are expanding. Therefore, the volume is increasing. So that's how we can simply explain, isn't it? Can you understand it? Raise your hand, those who understood that. Do you have any doubts there? Simple, right? Very simple. Right, okay. Now, students, now let's move to the next question. They have given, define the terms. Yes, what are the doubts you have? So gas molecules are far apart and they are randomly arranged, right? Then how? Randomly arranged means they are moving here and there, right? That means, so now try to understand it this way. So here we are talking about the, so this is actually not the volume of the gases, volume of the container, right? Right. So now don't misunderstand there. In the PV equal nRT equation, I told you that pressure is created by the collision of the gas particles when they are striking on the wall of the container, they are increasing the pressure. And I told you that gas particles are point masses. Compared to the volume of the container, volume of the gas particle is negligible. Then in that PV equal nRT equation, V, volume means not the volume of gas particles. Then what is it? Volume of the container, students. Volume of the container. So when the speed of the particles are increasing, we know that they are striking on the wall of the container, then more collisions, then expand, which what is expanding? Not the gas molecules. The container will expand. So when the container expanding, what will happen to the volume? Volume is increasing. So here volume increasing means not the volume of the gas particles. According to the kinetic theory, we consider that gases are point masses. Understood? That's a good question. Right? Rana, can you understand now? Is it clear now? Good. Right. If you have any doubts, put the doubts in the chat box, okay? Now, let's move to the question number 4. Define the terms diffusion and Brownian motion with examples. Right? So, we know that diffusion means, right? Diffusion means, as I told you, that is actually a spread of particles. Spread of particles. So the example, very practical example that I can give you is perfume bottle. Right? Then the next one is Brownian motion. I told you that one, right? Brownian motion means the molecules are arranging, the molecules are moving in a zigzag way, right? So I can tell here zigzag motion goes by collisions. This is applicable for any gases, ideal gases. So here, as an example, I'll give you a chart, a drawing of this one in this way. This is the zigzag movement of those particles. Right, like this. So this is the Brownian motion. Okay. Now let's move to the question number 5. Differentiate between evaporation and boiling. Right? So what is the difference between evaporation and boiling? Evaporation means so evaporation is taking place at surface, right? At surface. a process at a liquid surface at any temperature. And the most important thing, students, we know that evaporation is taking place spontaneously. That means we are not giving any temperature. So it will take place at any temperature. Okay. Then what does mean by boiling? So boiling means actually we are giving temperature, right? So I can say that a process with bulk amount at fixed temperature. So it's a fixed temperature, right? Boiling, it's a fixed temperature. Boiling point is boiling point of water is 100 degrees Celsius. That's a fixed temperature. But evaporation can happen at any temperature, right? That's the difference between evaporation and evaporation means a process at a liquid surface at any temperature. So boiling means a process with bulk amount at fixed temperature. Understood? Right. So these are again very simple things with gases. And you have to know some terms, right? So here I gave you some terms like melting, sublimation, evaporation, melting point, boiling point, diffusion, Brownian motion, ideal gas, kinetic theory. So you have to be familiar with these things. Okay. Right. Okay. Students, do you have any doubts regarding the things that we discussed today under these two topics? Is everything clear? Raise your hand, those who understood the things that we discussed today. If you have any doubts, you can ask me. Right. Okay. Then, students, the next thing I want to tell you is this will be the last session for our pre-A-level foundation program in this month. Okay. So we are starting unit number 1, atomic structure, on 7th of April. Okay. So April 7. We are starting unit number 1, atomic structure. Okay. So I have posted your tutorials, foundation tute and the unit number 1 atomic structure tute both, right? To the address that you have sent. So we are going to start unit number 1 on 7th of April. So Tuesday, and our regular class time will be 8 p.m. to 11 p.m. Okay, 3 hours. Right, during this foundation only I conducted only 2 hours, but get ready. We are conducting our theory class for 3 hours, 8 p.m. to 11 p.m. Okay. So next week, actually, you will have a holiday, right? March 31st, because I have arranged a seminar for 2026 batch. Actually, they are going for the examination on that day. Then we are going to meet on 7th of April with unit number 1. Directly, I'm starting unit number 1. So I have given everything, the introduction session. In the introduction session, I gave you what are the things you have to remember. I will introduce the syllabus, and directly I'm starting unit number 1. Right? You will get the PDF of the tute very soon. Admin Amasha will send you that one. So the remaining things in this tutorial will be covered by adding some extra classes in April month. Right? There are some remaining questions now. So therefore, I will cover those things by adding some extra classes for you. Right? In the April month. So remember that in the first week of April, we are starting unit number 1. And still, if you have any doubts and inquiries about the class, as I told you before, contact our admin. Admin Amasha is there. So her number is now 77 439 7430. This is her number. If you have any inquiry, anything regarding the class, you can send her a message and you can contact her, right? So get ready for the unit number 1 then. In the next class, we are meeting with the unit number 1. Do you have any doubts, anything? Anything to ask? Now you have an idea about what we are discussing, no? So today we did some calculations also. Now this is what chemistry is, right? This is what chemistries look like. In these 3 sessions, now you may have understood that this is our next 2.5 years going to be, right? We are dealing with calculations, we are dealing with the theories, we have some depth concepts, right? So here I have just touched the theories, just touched the calculations, but we are going to discuss more deeper things in the upcoming sessions, right? And I will give you our class plan, how the syllabus will be covered in the months wise, right? In these 2 months, this will be covered likewise. I will give you a form, that means a chart, then you can get an idea about how the syllabus will be covered. Okay. Any doubts, anything that before we wind up the session? I have posted your tutorials. You will get that very soon. Because of the issues that going in the country, because of this petrol issues and everything, your tutes might be late, because post office also told that these things can be late because of these issues. Okay, but anyhow, before the next class, definitely you will get the tute. Any doubts? Is everything clear? Yoshita, Sudesh, Pritara, Rishi, Kesan, Prahana, Rabha, Nilukshika, Metuki, Nimandi, Aaron, Mark. Do you have any doubts? Anything? All clear? Right. Okay. Okay, students, then let's meet on the next class. Until then, bye bye. Have fun. Good night for all of you. God bless you.